Hello everyone, for this video we're going to talk about circumference and area of a circle. First, what is our learning target for this video? I can solve the problems related to the circumference and area of a circle. Okay, let us recall first what is a perimeter. It's either a path that encompasses, surrounds, outlines a shape in two dimensions, or its length for one-dimensional. And commonly, you are describing perimeter as sum of all the sides, which is actually refers to the formula in getting the perimeter, which is also correct. Now let us have our sample illustration so that we can check if you can still remember how to get the perimeter of the given figures. So here, as you can see, we have a three-sided polygon, and going back with our description, so if we talk about perimeter, that refers to the outline that surrounds the given figure. And with that, if we are going to get the perimeter of this manually, so we can have our yarn or thread to trace the outlines all over this given figure, and after that we can stretch this horizontally and measure using our rulers or measuring tape, and after that then we can have our perimeter already. But if you're going to think of it, what if we are dealing with longer dimensions, like for example 100 meters and so on, so it would be difficult for us to provide some thread or yarn to measure or trace the outline of the given figure. And with that, we can apply the formula instead for perimeter, and simply we can have sum of all the sides. So with that, we can have 15 plus 15 plus 12. Therefore, our perimeter is, so simply add all of this, so we can have perimeter is equal to 42 inches. And we're done. Maybe others are wondering if we are supposed to write 42 inches only or 42 square inches. So actually, for perimeter, we are going to write 42 inches only. But if we're going to talk about area, then that's the time for us to put square in our unit of measurement. So take note of that. Next, we have this, another four-sided polygon, and as given, we have 25 centimeters, and we do have here the thick lines. Therefore, that indicates that all the sides are equal. So we can have 25 plus 25 plus 25 plus 25, or simply we can apply multiplication here as well. We can have 25 times 4, and therefore we can have our answer would be perimeter is equal to 100 centimeters. Okay, and we're done. So not all the times we are dealing with shapes with sides. Sometimes we deal with circles. Now, but of course, since based on the description of perimeter, it is a path that encompasses or surrounds, which if we're going to look at a circle, we can also have this outline that surrounds the given circle, right? So that means we also have the idea of perimeter for circular object. But if we're going to look back at the description here, referring to the formula of perimeter, sum of all the sides, we all know that circles doesn't have a side, and therefore perimeter may be not the proper word for us to use, referring to the outline that surrounds the given circular shape or object. So what would be the proper term we are supposed to use referring to a perimeter as well? Okay, so that is what we call circumference, and now that is what we're going to talk about in this video. Okay, so take note, the perimeter of a circle is called its circumference. So what do you think will be the formula for circumference of a circle, because we cannot use sum of all the sides, right? So for circumference of a circle, our formula would be product of d and pi, or twice the product of pi and r. To make it more precise, so we have this: c equals pi d, d stands for diameter, and c equals 2 pi r, so r stands for our radius. And of course, aside from circumference, we're going to deal with area, of course, of the circle also. So we can have our formula is pi r squared. Okay, so before we proceed with our sample activities for this, I have something to share you, a theorem that is related to our Greek symbol here, which is pi. So here we do have the pi theorem. It says that the ratio of the circumference to the measure of the diameter is the same for all circles. Now let's say, for example, we do have small circle and we do have big circle. Now you get the circumference of the big circle, and then you divide that circumference that you've got divided by the diameter of that big circle as well. Then after that, you compare it with the ratio, or let's say you get the circumference of the small circle again, and then divide it with the diameter of that small circle, and then whatever your answer there, you compare it with your answer in the big circle a while ago, and based on pi theorem, you would have the same ratio, whether it's small circle, big circle, or bigger circle. So that refers to our pi theorem. For our first activity, we are going to find the area of a circle given the following data. So first, let's start with the radius is 26 centimeters. Now, of course, we need to have our formula for area, and that is pi r squared. Okay, so let us substitute already, so we can have area equals pi. So I'm gonna substitute the approximate value of pi that we're going to use later on. So for now, let us focus with our radius, which is 26 centimeters squared. So don't forget the exponent, which is 2. And now let us simplify further. What is 26 squared, or 26 times 26? That is 676, and centimeter times centimeter, so we can have centimeter squared. Okay, so I would like to suggest that we are going to multiply 676 with the approximate value of pi, which is 3.1416. So we are going to multiply this, and we will be able to get the approximate value or answer for our area. So simply multiply those, and we would have area is approximately equal to 2123.72 square centimeters, or centimeters squared. And therefore, this is our final answer. By the way, I make use of approximate symbol instead of equal sign because we involve the approximate value of pi here in our solution. So we multiply it with the approximate value of pi only. Therefore, our answer is also an approximate value. Okay, so moving on, for our next example, as you can see, the radius or diameter is not directly given. Instead, we do have circumference. And therefore, we need to discover first, or find out, what is the value of the radius or diameter that was used to get the circumference, which is 80 pi. So we need to go back with the formula itself of our circumference. So substituting here in our formula, we can have, since it's given, circumference is 80 pi, so we can have here 80 pi centimeters equals, we do have our pi d. Now, so here, our target is to get the value of diameter. And of course, we all know through diameter, we can get as well the value of radius easily, because we all know diameter is twice only of our radius, or we can have vice versa, the half of our diameter is considered our radius already. So here, so we can simplify it. So isolate first our pi. So we can isolate it. So here, divide both sides by pi. So we can have this. Our diameter is equal to, so 80 pi centimeters divided by pi. So we can have 80 pi. I mean 80 centimeters. So therefore, our diameter now is 80 centimeter. And since for our formula for area, so we are going to use the area which involves radius. So therefore, let us get, so through this given data, we can have, since diameter used is 80 centimeters, so our radius would be 40 centimeters. And now, we can now proceed with our formula of area so that we can get our measure for area already. And now, since we got 40 centimeters, so let us just simply substitute it here. So pi times 40 centimeters squared. Okay, now we can have pi. So later on, I'm going to substitute the approximate value for pi, but let us focus first with the radius itself. So 40 centimeters squared, so that would be 1,600 centimeters squared. Okay, and now, so let us multiply this 1,600 square centimeters with the approximate value of pi. So I'm gonna write it here, so we don't have enough space. So approximate value is 3.1416. By the way, this should be approximate. Okay, now multiply with 1,600 square centimeters. And therefore, our approximate value or answer for area would be 1,600 times 3.1416. Therefore, we would have approximate answer, which is 5,026.56 square centimeters. So by the way, I'm considering our final answer is in decimal form, and I'd like you to round it off the nearest hundredths. So therefore, we do have this 5,026.56 square centimeters, and we are done. So as easy as that. What if here in our next activity, the area is already given and we are supposed to find the length of its diameter? Now, of course, let us make use still of our formula. Now, substituting, we can have area is 49 pi centimeters squared. Okay, now I can have pi r squared. Of course, here looking at this, our target is to get the value of our r. So we all know the relationship of our radius to its diameter. So if we will be able to get our radius afterward, we just simply multiply it with 2, and therefore we would have our diameter. So now, to isolate r here, so we can simply divide both sides by pi. And therefore, we can have r squared, and then we can have 49 centimeters squared. And here, so of course, this is not yet our final answer. We need to simplify it further by getting the square root of both sides of our equation. So we can have, so what is square root of r squared? So we would have r, And square root of 49 is 7. Square root of centimeter squared is centimeters. And therefore, our radius is 7 centimeters. But of course, since the question is, what is the length of the diameter? Therefore, our diameter will be equal to, so 7 centimeters times 2. And therefore, we would have 14 centimeters for our diameter. So this would be our final answer of 14 centimeters. Okay, so for our next figure, we are supposed to find circumference this time. So now, of course, if you're going to look back at the formula of circumference, we need the detail on diameter or else radius. But here, as you can see in our illustration, we don't have any detail for radius or diameter, but we do have this clue or hints. We do have this integration of our concept on triangle. The two sides of the given right triangle are given, which are 15 and 8 centimeters. Now, as you can see here, looking at the parts of our triangle, the hypotenuse is the opposite side of our 90-degree angle. Therefore, we can use the formula for Pythagorean theorem to find the measure of this hypotenuse. And as you can see, our hypotenuse is considered our diameter as well. So therefore, we can start with our Pythagorean theorem first, which is c squared equals a squared plus b squared. And of course, to make it more precise, so let's make use of the names of corresponding segments. So we can have CW squared equals OW squared plus OC squared. And substituting, we do have CW squared. This is what we're going to look for. And our OW is 8, so 8 squared. And our OC is 15, so 15 squared. Now, so simply copy CW squared. Then we do have 8 squared, so that is 64. And 15 squared, that is 225. And now combining it, so we would have CW squared is equal to 64 plus 225. We do have 289, but of course this is not yet a final answer. Square root of both sides of our equation, so we would have CW is equal to 17, and of course I'm gonna write the unit of measurement instead to make it complete. So therefore, the hypotenuse here is, we can have 17 centimeters. So this will be our hypotenuse or our diameter. And now we can proceed with our formula for circumference. And now we can use our formula for circumference, which is pi d. Okay, and substituting in our formula, so circumference is approximately multiplied with 3.1416 times our d. We got 17 centimeters a while ago, and therefore our approximate value or answer for our circumference right now, so 17 times 3.1416, and we would have 53.41 centimeters. So this time we are not going to put square for our unit of measurement since we're dealing with circumference already. And reminder again, so you are supposed to round off the nearest hundred. So we would have 0.41 centimeters. Okay, and that's it. For our last problem, we do have the circumferences of two concentric circles differ by 10 inches. Compute the width of the ring between the two circles. So let us have our simple illustration for that. So concentric means two circles having the same center point. And as you can see here, we are supposed to compute the width of the ring. That means we are referring to this part. So the width of this ring. So now, here in our given problem, the radius is not directly given, right? So with that, we are supposed to represent the radius of our small circle here and then the bigger circle. So here, as you can see, let me draw the segment that represent the radius of the smaller circle, and let us represent it by r. And what about for our bigger circle? So we are going to put here again simple representation for our radius of the big circle, and let's say the additional distance of this would be represented by x. Okay, so with that, we can say that the radius of the small circle will be represented as r, and the radius of the big circle will be represented by r plus x. So that means this distance of the radius of the small circle plus the additional distance, that is why r plus x. And as mentioned here, the circumferences of the two concentric circles differ by 10 inches. So that means we can have our equation and it involves subtraction. So we can have circumference of the big circle deducted by the circumference of the small circle, and therefore the remaining portion would be this, which represents the width of our concentric circles, and it differs by 10 inches. So this would be our equation. So of course, let us get the circumference of the big circle and then the small circle. So I'm gonna put the formula first. So circumference is 2 pi r for the big circle and 2 pi r for the small circle. Of course, we do have the same formula for that. And substituting the expressions that represent the radius of each circle, so we can have here, so for our radius of the big circle is r plus x, so we have here r plus x, and for the radius of the small circle we do have r. And then, so of course, let's have distributive property, 2 pi times r, 2 pi r, 2 pi times x, 2 pi x. Simply copy the 2 pi r here for the circumference of the small circle. And of course, as you can see, we do have like terms here. We are supposed to combine 2 pi r and the negative 2 pi r, and with that, so we can cancel this out, because 2 pi r minus 2 pi r we would have 0, and therefore we would have 2 pi x would be the remaining expression at the left side. So 2 pi x equals 10 inches. So but of course, our target is to find the width, so that represents the x. So we need to isolate x right here, so we can divide both sides by 2 pi, and there we go. So we do have divide both sides by 2 pi, so we can cancel this out, and there, so we would have so the remaining here would be x, then 10 inches. Then I already substituted the approximate value for pi that we are using, which is 3.1416, and with that, 2 times 3.1416, so the product of that will be divided from 10 inches, and there we would have x is approximately equal to 1.59 inches. This would be our final answer for this problem. So again, round off your answer to nearest hundredths place. Okay, so thank you so much for watching this video. I do hope you learn a lot about area and circumference of a circle. See you on our next video, and again, thank you so much for watching.